Thank you. My name is Alexander. I'm in charge of technology at Podder.io. It's a pleasure to be here and to share this space with you at this great event. And today I'm going to share with you the story. Oh, it's okay. To share the story how we came up using Driverless AI in our company in production, what our plans regarding Driverless AI, and what problems and challenges we have with it. So next slide, please. So I will proceed with a short introduction of the company, then how we are using H2O, what is the specific support for Driverless AI we have, and then concentrate on the case with predicting medical test results we had with biology. Please. Next slide, please. The main product of our company we are working on is a prediction as a service platform called Epica. So what we are doing is collecting huge amount of data from various sources. This is web pixels, so some JavaScript injected on web page. There is mobile SDK for iOS, for Android. There are some APIs. There are third-party systems we integrate like CRMs. We collect all the data. We normalize it and standardize, enrich this data, and put it into the storage. This is data engineering part, very challenging itself. But then we come to modeling. And modeling was the most challenging part from the very beginning of the company, because our goal was to generate insights out of the big data in real time. And all three parts are very challenging. And in order to combine it, we need to do something extraordinary. And on top of that, automate everything. And actually, again, data engineering part and DevOps part is very important, because what we're doing daily, we're pulling new data, we're training new models. We should verify and test that the models are okay with the performance. They outperform previous models. We need to make a decision if we need to substitute old models or not. Then we need to package these models as deliverables, like API, like small application, Dockerize them, and send to various servers, either for clients or on our cloud. And after that, we go to the next step. Next step is segmentation. As for models itself, there are various models. Several dozens of them are in production, like predicting what your audience is going to do and when. For e-commerce, for instance, there can be models predicting that this segment contains most probably those people who are going to buy something next month or next week. Or this segment is about people who are going to consume this type of content, if we are talking about publishers. And many cases like that. And each case is quite specific, because sometimes accuracy level is critical. And if you're over 0.9, you are bad. But sometimes, for big numbers, even 0.7 as accuracy is very good. It's very good, very good. So there are diversity of these models, and we need to deal with it in automatic way. This is a challenge in itself. Then we segment all data, all audiences, and allow our clients to, with various interfaces, to create segments and activate them. Activating means running ad campaigns, running email campaigns, running SMS campaigns, whatever. The place of H2O here is essential. And please, next slide. Is essential. From the very beginning of the company, we decided that our framework will be H2O just because of one single killer feature is deployment as Podder and Moja, because it's very simple. It can be done automatically way. It's very performant. And that's the king. That's the king in this pipeline. And daily we're using various models for regressions, classifications, for text classifications, and actually Word2Vec, this embedding model we're using not only for text. We're defining some models out of events. We define each event as a word, place embedding out of these events, and surprisingly, but these models are quite performant. So Voltovec is also a very great tool and model to look at. We're excited to hear at our keynote session that time series were actively evolving last month, and we're eager to see how they implemented it driverless. And many other, almost any single model that H2O has, we tried, we played with it, and most of them are more or less in production now. And next slide, please. And at some point, when driverless was in beta on the market, we had a chance to try it. And there is a very interesting case I will talk a bit later. But we were excited of those elegant way how it can be introduced to production. And we are not brave enough to substitute human right now in our pipeline. So at the moment, we have two points of application of driverless. First one is just a benchmark for all our models. It's very easy to execute it and very easy to check if our models make sense or not. If we're around something that driverless can generate in 1 hour, so we are okay. The problem we had with driverless several months ago that, well, we're trying to keep things as simple as possible in production because it makes sense. If you automate hundreds of models and building complex pipelines, you need to keep things simple. And driverless in production was quite tricky. But about a month ago, in late April, there was introduced a Pozha-Moja export from driverless models, and it changed everything. Now we're trying to move it in production, and I think that in Q3, we will be there. And already have many cases that we tested them, and I'm almost sure that they will be in production soon. And taking in mind all those new nice features that we listened about today in keynote session, that it should be great. And also we have research department for managing our big clients' cases like medical companies, brands, etc., etc. And driverless for consultancy is very so unique product. I would say it's unique because it solves many problems out of the box. First problem is to manage this complex data, because inference stage is, well, very tricky. So analytical stage, inference, so feature engineering, everything is quite tricky. And if you can get out of the box fairly good results, so you can move much faster. And second part, which is important for us and for the clients, is interpretability, exploratory part. And that's the case I will be talking the rest of the time. Next slide, please. Yeah, this is the legal disclaimer we should make, that this research I'm going to talk about was supported by Bayer. Oh, please, next slide. So the case is, unfortunately, I can't talk too much about details, but on high level, I can explain the case. So it's about choosing the correct treatment strategy. When patient comes to the physicist, it should decide which strategy works best. And with some specific diseases, it's very important to choose the dosing of the treatment. And well, in most cases, in our case, in Bayer case, in most cases we had no data for it. So treatment was strategy treatment was quite tricky because it's human after all, and we can't risk a lot, right? So what they're doing right now, they're making traditional experiments, and traditional experiments mean that each human in a control group, in a test group, costs like 20K just to run the experiment. You need maybe 20, 30 people in these groups, and quite costly. And we decided to do a data-driven approach to take the data they have from different claims and create a model which can help to generate some insights, even in case of missing data. So next slide, please. So in our in our database, we had inpatient data, outpatient data, and pharma data from one large data set they provided to us. And our goal was to conditionally the history of client, even with missing direct measurements, conditionally predict the probability of certain level of the test, this laboratory test. And the reason to have it is a check tool, diagnosis tool. It is not used directly. Again, the final decision is up to physicists, because again, it's human being. But it's very important to have this tool to cut some cases from the beginning. So please, next slide. So the design of the experiment was something like taking the data. It was kind of 1 terabyte of data and 4.5 million patients, then cleaning, feasibility check from medical point of view, then validation, filter it out some invalid data, then adding some noises, adding some extra variables, then splitting into train test subsets, cross-validation, everything. And traditionally, we started with H2O models, which are working good for this case. This case was regression case, so we tried GLM, elastic net, GBM, random forest. And the story about it is on the next slide, please. Oh, yeah. So data itself for 10 years, 11 million wide records. So each record is a full case of a patient during 1 quarter. So each record is 200 something variables filled. Of course, there are some missing variables, but anyway, this is wide record. We have, after all, 4 million unique patients. We split this into train test, and number of raw features is on the slide. Please next. Yes. What we did initially was ETL, of course, then spent maybe several months for feature engineering, testing, inference, and everything. And here, also data table helped us a lot. And then we trained several models. And we went to present our results to buyer side. We had 2 days workshop. And first day we were discussing everything, how smart we are, which features are good, and everything. And at the end of the day, it was a surprise that they don't really need it. And please, some details on the next slide. Yeah, so we started with GLM. We spent some time on coding. Of course, this coding time is time after inference and feature engineering, everything. Just script coding for this specific model, for machine learning specifically, not for data analysis and cleaning up. It was GLM, GBM, random forest. We spent some time on assembling. We got very good results. And after all, the question was, how can we interpret it? How can we explain it to the physicist? So physicist in his office is not going to use your API to call your endpoint to generate some predictions, right? This is not the case. He's not going to trust your black box model anyway, because it's a black box and this is human. So what we're going to do with it? How can we explain it? And we need simple prescription how to do. As simple as, I don't know, if you're age less than 10, you need this dose in 10 milligrams per kilo. If you're after age of 10, it is 20 milligrams per kilo. And nobody knows what happens to the kid in the night before his 10th birthday. But anyway, it's how it works. So, and we said, well, what if we do some surrogate models to explain our black box? They said, yes, but tomorrow is the last day. What we're going to do? We said, let's try to do something. We go to the hotel, executed driverless AI, and went to sleep. In the morning, we generated some slides, and our deployment of the model was like the tree on the last slide, please. Yes, we show this tree, and this tree is very simple. If your age of less than 60, then you go to the left. If you have some diagnosis like that with this code, less than or more than, you go to the left or to the right. So this is a simple decision tree. They said, yeah, it works. This is deployment, not API, not some black box model we do not understand, just simple tree. We said that, okay, we need to do some claims that this is just explanation of a part of our Black's model. They said, okay, we'll live with these simple prescriptions for years, for decades. It works. We need some tool for diagnosis, but we make decision ourselves. And yeah, this is the deployment model. And on the next slide, some exploratory parts also were generated out of the box during the night while we were sleeping. Some explaining of the age. When we show them these plots, they said, yes, that absolutely makes sense from medical point of view. So you explain this. Its test results with your age will be, should be lower. That's okay. So that was the case. And this story of driverless in our company is a bit complicated. We started as consultancy. It was a very good case for consultancy with Bayer, when driverless, well, saved and helped us to prolongate the contract. And then we decided that why not to go to production with our main product. With our main product, we need to automate many things. And if we need to automate this pipeline, why not to use driverless? And of course, we'll be checking it, but maybe at some point it will be well, okay, auto AI or something like that. We will be stuck with data engineering only, which is tricky part itself. Yeah? Of course, driverless will not cover all cases in nearest future, but there are many cases where you're doing business at scale, and when you do business at scale, so your models, your execution should be simple, because it's impossible to execute something very complex at scale. So it's just impossible. So I think that we will see in 1 year in next H2O World how it works in production. Well, thank you for your attention. Okay, thank you.